So, hello, hello. So, hello there. Yeah. So, I think I'm just gonna record a quick introduction to C because I think I owe you a little C tutorial for a long time. Don't I? I think we're a little bit of an overdue for a bit of for some C programming. So, this right here, what you see is C. Yep, not C++, not C#, it's C. The original good old C programming language. Looks a little bit like C++, a little bit, but there's going to be some major differences that we're going to get into. So, I am gonna go through this very slowly because this is gonna be very hard. This is gonna be very hard. Like, I'm gonna tell you right now, this is not gonna be easy, but there is definitely it's definitely possible to learn. Okay. It might be a little bit intimidating from the beginning, especially when you feel like there's a lot of stuff that's being thrown at you that you don't quite understand. But don't worry, we're going to go through this step by step and start from the very basics of just writing up a simple hello world program to structs eventually. So there we go. So that's the little introduction to this new series on C. I will take you mainly this is gonna be mainly for like beginner oriented to like intermediate. Like, we're not gonna be doing like modifying the printf function and stuff. Like, we're not gonna be doing any of that because that's not the point of this tutorial anyway. This is mainly to make C a bit more accessible to people who might have never programmed in this language. So that's the point. I feel like accessibility is one of the main problems of the C programming languages anyway, as it is. So let's just stick to easy beginner concepts as it is now. So if you boot up any C program, you will see something like this, int main, and it returns 0. So that's basically how every C program starts, and this is actually where, if you ever programmed in C++, you had the int main function, right? Well, this is actually where it comes from. So the C language originally had this int main function, and then C++ just built on top of it. So this is where it comes from. This is exactly where the origins of the int main function is. It's right in this programming language right here. We are specifically going to work in C11. So that's the standard I'm working in, just putting it out there. So this is going to be specifically C11. As far as this is. And obviously, one thing you have to remember about C is that there are some things that are very similar platform to platform, but when it comes to C, everything in C is very, very heavily platform dependent. So whether or not you are on Linux or Windows, it's all platform dependent. So Windows has its own libraries that are defined by Microsoft and maintained by Microsoft, and Linux has its own libraries in C supplied by the GCC compiler. So you always have to check your compiler include files for C, for the C programming language, because every platform has different. So C is not cross-platform, okay? A program that's built in C that's meant to run on Windows will only run on Windows and not on any other programming language. It will not run on Linux. It will not run on Ubuntu. None of these. It will specifically run only on Windows. And a C program that's designed to run specifically on Linux will only run on Linux. And that's what you have to remember when programming in C, is that you can completely just imagine this box right here being cross-platform programming. And now I want you to grab that box and throw it out of the window completely and forget about it. Because there is no such a thing as cross-platform when it comes to C. So just completely throw that idea out of the window. Forget about it, okay? You can also completely throw the idea of multi-threading out of the window, because we're only working with single thread, because this is C and we don't have multi-threading. There is a Linux-based implementation of multi-threading for C, but that is way too advanced, and we're getting way too ahead of ourselves at this point already. So let's just get started with the basics, shall we? And not about these about these advanced concepts that are way too nebulous for us right now. So let's just get started. So so we start by simply including stdlib. So this is the first include that you need. So this includes the printf function. So this will give us malloc and calloc, which are two functions that we will talk about later. Then we want to include stdio.h, which will give us the printf function. Specifically, we're going to be using the printfs function because it's the secure, it's the modern function, the most modern C function, and it works exactly the same way as the old printf, so there is really no reason to not use it. So there we go. So these are the two includes that we want to have. So stdio right here, this handles standard IO. So that would be your input/output. There we go. So input output, so printing, and it also gives us the gets function here. We're going to be talking about that. So it allows us to, again, so this library right here allows us to print stuff to the command, it allows us to print stuff to the console and read user input. stdlib, here, you mainly want these for the malloc function and calloc function, which we'll talk about later. You can also, for example, include optional libraries like memory.h. This will give you something like the memcopy and etc. So these functions are basically used to copy strings around. We will talk about it later. So for now, but for now, we'll talk about this later. And even Linux distribution should have stdio, stdlib, and memory. Even Linux distribution should have these libraries as well, since these are built-in libraries. So literally, this should be on every. I think even GCC should have these as well. So these are not Windows-specific libraries, but when we're talking about a library like, let's say, the windows.h header file, which contains lpcstr, the long pointer to constant string, that will, so this, for example, this header right here, the windows.header, is obviously Windows specific. So this header is maintained by Microsoft, it's Microsoft defined, and it, for example, contains stuff like it contains like lpcstr, for example, which is basically, so right here, so it contains, for example, this is Microsoft defined. If you ever want, so I'm just going to mention this on whim. lpcstr stands for long pointer to constant string, which is basically the same thing as doing which is basically the same thing as const char pointer string. So basically it's the same thing like this, but so you don't need to know that as of now. I'm just trying to showcase you the difference between the platforms. For example, Linux, so if you're like Ubuntu, you will not have that header. So you would have to, you will not have that header, basically. So I just wanted to basically showcase you the difference between the platforms when it comes to C. But realistically, that's all you need to really know. You can forget about that. The only thing you really need to take care of, those examples I showed you there, was just the fact that there are different libraries for Windows and different libraries for Linux. That's all I wanted to show you. So you don't need to remember the lpcstr, so you don't need to remember that as of now. So right now we just want to focus the specific on the printf. So right now I'm basically want to show you the printfs function. So this is the one that we're gonna do today, which basically prints to console. There we go. We're gonna be explaining the gets safe function right here. So it's basically getting user input, so we're gonna be talking about that as well. So how do we actually get input from the user? We're gonna be using here something called buffers, or basically char arrays like this. We're gonna be talking about what these are and how we actually allocate them. So please keep in mind that for the purposes of this tutorial, all of this stuff will be stack allocated. It will be stack allocated. I'm gonna guide you through it very slowly. So we're gonna be allocating all this on the stack first, and then we're gonna use, for example, the malloc and calloc are used to allocate items on the heap. So this tutorial is like the first introduction. We will just use how to allocate your variable, how to allocate buffers on the stack, how to allocate strings on the stack, how do we basically just get user input, and how do we print stuff to the console. That's literally all that I want to show you right now, just as a quick introduction. But don't worry, it will all make sense. So I'm assuming that you have all these two little include files included here. With that, we can start programming. So what do I want to talk about? Yes, the printf. So all you need to make it, let's start with a hello world program, a nice little program that everyone knows, right? So there's many ways we could go about this. We could straight up just allocate an array on the heap, and then copy a string into that memory address and then print it. But that's very complicated. So the simplest way to obviously to make a hello world program in C would be use the printf or printfs function. In this case, I'm going to use this one. And as you can see, so this function takes something called a const char pointer to a const format, right? So it's a parameter code format, and it's a const char pointer. So what is a const char pointer? So you will see this a lot. So you will see this, a const char pointer, and then here we have a var name, right? So you see this a lot. So what actually is a const char pointer? Well, a const char pointer is something that you would call, let's say in Python, a string. It's essentially an array of characters. So if I basically gave you a word like hello, we can break this word down to individual bytes. Every char is a size of 1 byte. Therefore, this word, if you count it, has 5 bytes. So this is a string that's 5 bytes long. Okay, makes sense. Pretty easy. So a const char pointer is basically a string. So you can even do. I'm not going to explain to you that now. But a const char pointer is a string. It's the same thing as basically if you remove this and put this here, you can then allocate, for example, the size. But this is used like this. So this is how we declare a string in C. So you go const char pointer, you put your name of the variable here, and then you, let's say, put a string like hello, right? This is how we would initialize a string in C. Variable initialized string. There is a difference when we initialize a string when we don't know how long our string is. We'll do that differently, but so far let's just focus on declaring variables like this. So a const char pointer is just a string. That's all it is. It's a string. That's what basically we would call it, like in Python or any other programming language, a string. The thing is that strings don't really exist. There is no such a thing as a string, like a type. It doesn't exist. A string is basically just a series of bytes that go after each other that just happen to be the ASCII values for the letters. So that's basically what it is. So in memory, this H would basically be like let's say so in memory you would have something like this. So you would have basically your first memory right here, and here you would have the value let's say 65, and then you would go to the next window right here, and then would have 66. And then these two values get interpreted by your computer as letters, and they get displayed as letters, depending on the file descriptor that you choose. But this is basically how a string looks like in memory. It's basically just a bunch of values that go after one another for like 5 times. So this would be 5 of these numbers right here. So you would have another here, right here, so 67, and then here you would have, let's say, 68. So this right here would be a string of 1, 2, 3, 4 bytes long. And then, actually, before I forget, there is a 0 right here. So this is how a string looks like in a memory of a C program. It's not hello, so this would be A, B, C, D. So this would be a string A, B, C, D. So this string, so this is a string A, B, C, D. This is how it would be saved. So it's just numbers. 1 byte each, right? So it's basically just numbers, and they're of size 1 byte because a char is basically just 1 byte. So basically you can also think about it like this. So 65, 66, 67, 68, and 0. You know? So there would be your... Here would be your... So this is how it would be. And since you only need 1 byte to be able to save these numbers, because those numbers only go to like 122, you really don't need more bytes. You don't really need to waste much memory. Plus, you know, it kind of declaring the char, it also kind of gives instructions to the computer about like how to actually display the data and actually save it. You know, if you think about it, a char is just in a way, just an unsigned, I think it's unsigned short, but we're not going to get into that later. So this is roughly something like what a string ABCD could look like, you know, and this null here, that's what we call a null terminator. So this null terminator basically signals to your C program that, hey, this is the end of the string, please stop reading here. So that's what this null does. So actually this string ABCD right here, 1, 2, 3, 4, has only 4 letters, but it's 5 bytes long because of this null character that signals to the program that, hey, this string ends here, please stop reading. Without this null terminator, we would basically read memory that doesn't belong to us, and there will be a bunch of uninitialized garbage that would make no sense. We're all gonna show this to ourselves later, but a bunch of theory that you need to know. So a const char pointer is basically just a string. That's all it is. It's a string. You declare it like this. So this is how we would declare it. So this is, for example, so how to declare let me just use the quotes, string in C, because strings aren't really a thing that exists as a type, so that's why we have, so if you really strip away what a string is, like if you really strip it away, and if you really just look at the raw data of a string, it's basically just a const char pointer. That's all it is. So this is how we would declare a string variable in C. So I'm gonna show you how we can basically do it by value. So you've seen, so now we can actually move on to the printf function. So here we see const char pointer. So it's a string and it's a format. So basically we can use a format. So for the printfs function, or any printf function, it takes in a format, which could be something like this, or something like this, or something like this, unsigned digit or whatever. The point is that your format is always the ampersand and then either D or S or U or whatever. This D would be an integer like this, and then your S would be a string, or as C likes to call it, a const char pointer. So that's basically what this is. So now if you want to print the string, hello world, ideally what you want to do is define your format. So my format is this. And then here we want to pass in what we want to print. And you will see this little quirk about C. Yeah, you might see this little quirk about C. So you might be looking at this and you're like, okay, great. So we covered what the const char pointer means. Okay, great. So we covered what this is, right? We now know what the const char pointer is. It's a string that specifies the format of what we want to print. But then you'll notice this weird thing called this 3 dots right here. And that's called like a vararg, that they call it a vararg, or a variable argument. It's called a vararg, basically. And it only exists in C. So I don't think C# or C++ have this functionality. But we will get to this later. This is actually some like very interesting fun thing. So this, you know, this is basically allows us to pass in a variable amount of arguments, just like we would in Python, which is freaking crazy, isn't it? So you know the arguments when you put the asterisk and then args in Python, and it allows you to pass how many arguments you want. That is exactly what this ellipses in C does. It allows us to pass how many arguments we want, which is freaking crazy. Like I think that's pretty awesome. Like literally no other C languages have this functionality. Like C is the only language that does this. I might be wrong, but I don't think C++ supports this. I might be wrong. I have never used it in C++. I've never seen it in C++. I've only seen it in C. But it exists in C and it's awesome. So here, when these ellipses are, so this is where we wanna pass in our string at this ellipses little vararg argument right here. So the string that we wanna print, hello world, is actually our vararg, right? And obviously we end with semicolon, just like in C++. So basically you wanna specify the amount of varargs that are here in the ellipses arguments that you need to match this. So the amount of format declarators you have here need to be matched by the amount of stuff. So if you wanted to put another string here, you would have to basically put another string here, like this. So let's do the hello world program first. So we specified our format, and then we specified that we want to print hello world. So let's compile this and let's run. There you go. We built our first hello world program. So there you go. So just by doing this, we have officially built your first program in C. So you have managed to, so if you finished this, you have officially made your first C program. Well done. So that's basically how we would go about doing this. Now, it gets a little bit... Now, I'm going to also mention something brief about varargs, is if you include, I think it's stdarg. stdarg, this little library will allow you to manipulate the vararg argument, but we're going to get to that later. Now, there's another basics I want to also mention as a side note is that you might notice something is this stdio.h, and you might also notice that some have two versions. So for example, so if I include, let's say, memory, you will see that there is memory without a .h and memory memory.h. So you can see that we have duplicates. That is that this one over here is meant for C++. So this is a C++ header file, and it will even warn you saying that the current pragma pack alignment value is modified in the included file, which means that this header file is C++ aligned. And that's the reason why you want to put the H there, because the H explicitly says that we want the C file, the header file meant for the C language, not the C++ language. So we want the C aligned header file, not the C++ aligned header file. And that's the reason why you should always put the .h in there every single time you want to include. Just a little side note, I think it's important to mention, because I feel like some people might get stuck on that, and then they might, you know, find that their code isn't working for whatever reason. So I figured I mentioned that just to clear up the confusion. So always make sure to include your little h's with your header files here. Okay, great. So now you know how to print hello world, how to use the printf function. Okay, so let's actually, so let's move on. Let's move on a little bit. So let's talk about const char. So before we can work with the getS function, which we will explain in this video, we need to learn how to declare strings and how to store strings and how to copy strings. Okay, so you know how I was talking that a string in C is just a const char pointer? So this is how we declare a string. So let's do that. Let's declare a string to print with our printf function here. So let's declare a string. So what should our string be? So a string would be declared as a const char pointer. Let's call it name, and we put the equal sign, and we put the specifically we want to put the double quotes, because single quotes are for chars. That's the difference. So double quote, let's say so this is any length, so this is variable length. Let's say Mike. There you go. So now we have declared a string, as you can see. So we can declare a string like this if you don't know what length the string will be. So, you know, for example, let's print this a string right here with our printf function. Well, how do we do that? Well, we simply just pass in the stuff that we want to print. So here we just pass in a name, like so. So as you can see, this is, so we basically take this const char pointer and we just pass it here, like so. Awesome, right? And there you go. So now this program is gonna print C is hard. And remember, since this is a const char pointer, we need to specify this, add this %s to declare that we want to print a string. So we're printing a string here. So compile and run, and we see that it prints C is hard right here. Awesome. So now we know how to declare. So this is how you declare a string. Again, I encourage you to go practice this. Practice, all right? That's the best way to learn this. You gotta just go in there and get your hands dirty and really try this out for yourself. So that's how we declare a string. Actually, not that hard, is it? Like, this is every single time you wanna program a string, it would be a const char pointer. Const, if you don't need to reassign the string, if you need to reassign this variable, just omit the const. Char pointer, I'm gonna show you char pointer, string. I'm gonna show you that these two are exactly the same. That you don't have to. I'm gonna show you that name. I'm gonna show you that these two are exactly the same, just to prove my point, so people don't ask questions later. So here we have const char pointer name, C is hard, and char pointer string. And I'm gonna prove to you that both of these are equivalent. So they're both strings. There you go. As you can see, it says C is hard and str right there that we've put here. So the const doesn't actually have a bearing on whether it's a string. What makes a C string is this part right here, this char pointer. That is what declares a string in C. So as long as you have the char pointer here, C will treat it as a string. Now, I heavily encourage you, if you didn't know this, to just pause right here and to do this yourself, if you haven't done so, before we move on, okay? This is very important to take this slowly, step by step, just so we don't get confused, alright? So there we go. So that would be our strings done. So that's the basics of strings that you need to know. And we've also talked about the printf function now. Let's talk a bit about the get. So the gets function. So the function takes in a buffer and an r size t size, and this size right here is the buffer size. So it's the size of this buffer right here, because this is the save function. Remember, safe functions, make sure to use the safe functions, okay? They are the ones you're supposed to use. So this r size t right here, so don't worry about that. That's the r size t right here is basically just bytes. Don't worry about that. So the buffer size right here is the size of this buffer right here in bytes. And we'll talk about how we get there later. I'm just kind of trying to make you familiar with the function of getS. Because now we're going to talk about how to actually read user input. So how do we get, so now it's awesome. It's all great. It's all hunky-dory. We know how to print a string. Actually, maybe that reminds me. We know how to print a string. Actually, before we get to the user input, I should probably also talk about integers and whatever. We're gonna talk about structs in the next video, but let's just talk about primitives. So now we know how to basically how you can declare a string. Const char pointer name equals Mike equals Mike, right? So there you go. That's how you declare a string. The way you declare an integer is exactly the same as you would, let's say, in C++, that you've declared an integer. The way you would declare a char would just be a char C, and then you would do A. So this is how you declare a char. Just omit the pointer right here, and it will be a char. This pointer signals a string. We will actually discuss that later when we get to heap allocation. We will discuss why the pointer is what matters when declaring strings. So there you have, that's how you declare a char. A short integer, x, y, 1, for example. There you go. So that's how you declare a short integer. So this all stuff is basically the same way. Like if you're coming from C++, you would already know this. It's exactly the same way. I guess I should also show you how do we print, how we print, let's say, strings and integers at the same time using the printf function. To print a string, remember %s, and to print an integer is %d, and then to the varargs here, that's where we want to put our variables in the order as it's specified in the format. So first is a string, therefore we specify a string. Okay? Second is an integer, therefore we specify an integer. And this will basically give us Mike1. As you can see, indeed gets printed Mike1. So I don't really want to bother you with the memory, but this right here is this right here is 1, 2, 3. This is 5 bytes right here, and this is 4 bytes. 4 bytes of memory. This will come in handy very later. I'm gonna explain to you why this is important later. But I'm just kinda, I need to explain this to you because this is kind of important in C. But we will talk about this, why this is important later. So there you go. So now you have basically successfully printed a string and an integer into the console. So well done. I mean, this is already quite nice, quite good. So let's continue. I'm gonna now show you. Yeah. Okay. Alright, so we can print, stuff to the console now. Like, like that's all hunky-dory, that's all beautiful and amazing. We are able to print shit to the console. Well, and I think you're probably asking, but Mike, how do we actually get input? Because you obviously, if you want to print something to the console, you also probably want to read the user input as well. Alright, so how do we actually do that in C? How does one read user input from C in C? Good question. So that's what we're going to talk about right now. So remember how I talked about the gets function taking a buffer and an r size of buffer size? Well, this is where it's gonna all kind of start making a little bit of sense. So first things first, I'm gonna talk about pointers a little bit here. So declaring, let's say, a char pointer of a name, let's say hello, this declares an array. But stop right there. strings in C are very special little things, because while this does create an array, you need to remember that this does not, and neither does this. Okay, so don't get this confused. I think this should be. So basically, anything pointer is basically an array of that type. Yeah, as you can see here, incomplete image to pointer conversion. Initializing is expression type int. Yeah. So this is wrong. So right here, I'm gonna say this wrong. I'm gonna capitalize this because this is where a lot of people make a big mistake. Strings are kind of special little things in C. They don't really get treated the same way as other types. So a char pointer is not quite the same thing as an int pointer. So while a char pointer does create an array of chars, an int pointer does not create an array of chars. That is one big difference that you need to remember. Please, really remember this. This is gonna be so important, and you're gonna make that mistake a lot if you're not careful. So const char pointer name, let's say Laura, right? This does create an array of type chars that can be subscripted just like an array. So for example, name 0 indeed does give me a char. So back to our printf function. For example, we can specify name, right? So we can have name right here. Name, and let's say initial, right? So this would be Laura's initial, for example, right? So there is this quirky thing. So if we're still talking about these strings, so that is wrong. This right here does not create an array. We will talk about array creations later. Right now, let me just take you through. So we can indeed char pointer name Laura indeed is, so this indeed is an array of char, right? So this is an array of char. So is an array of char. So this is an array of characters, because that's what a string is. It's an array of characters, which means that we can subscript this. So we can say, so name, let's say 0, would indeed give us the char L. And this indeed is a char. So that you can subscript it like this. You know, since it's also kind of acting like a pointer, you can also subscript it like this, which will give you L right here. So the way we format for a char would be %C. This will give you a char. So here we have a name, and a name at 0 will indeed give you a char. And I will prove this to you right now. So as you can see right here, so this is our full string, Laura, as a name, right here. And as a string, formatted as %S. And then the initial here is L at 0. So this is how we can basically treat it. So we can treat it as a pointer, so it is subscriptable, just like an array, because it is an array. But we can also treat this like a pointer to get a slice of the name Laura. So for example, if I wanted to just print the last 3 letters of the name Laura, what I would do is here, I would go in and say %S, and I would basically say name plus offset. And in this case, we want to offset this pointer by 2. And this should print the last 3 letters of the name Laura. There you go. Last three. There you go. There are your last errors. So, as you can see, I gave you an example. Since this is an array, we can subscript it and get individual chars just like we would in an array, but we can offset it as well just like we would with a pointer, because it is also a pointer. So, strings are a little bit of a special little thing in C. They're not quite the same as other pointers are, and they're quite complicated. The strings in C are very fiddly and very confusing, but with enough practice, I guarantee you that you can definitely learn this. Just remember, really go and do this by yourself. Like, really get in there and try to like fiddle with this yourself, because that's the only way you're gonna learn it. Like, at the end of the day, I can sit here and explain this, just teach it to you all day, every day, all day for 20 hours on end. But at the same time, if you don't go and do this yourself, you will never be able to learn it. So always make sure to do this yourself, okay? I'm gonna give you a little quick hint. So S is a string, then %d would be an integer. So these are just a bunch of basics, and %c is a char. So there you go. So this is like a little cheat sheet right here, just to explain what each individual formatting options are. Okay, so now with that out of the way, that was a lot of things to... man, that was a lot to explain. And we are still not done. This is still just the beginning. This is still just the beginning. Get ready. Okay, so with all those basics out of the way, it's time for more basics. So great, we can format strings and we can print them to the console and we can do all this epic shit. Cool. Well, every good program also needs user input. So how do we actually get input from the user? Well, now with the knowledge that you know that char pointers is also arrays, we can actually move on to declaring a buffer. Ah, yes, the legendary buffer. So, there's another thing that I need to tell you. So, a char pointer name is identical to char name, and here we go. Here you specify your size. This is the same thing. These are identical. So as here we use this one to initialize strings that we don't know the lengths of. As you, for example, course char pointer name. This could be Mike, as you can see. This one's perfectly valid. Could be Laura or whatever, you know. It could also be, let's say, a Bob. You know, any size is good. It works. But this is just a raw string. We can't really do much with this. So now I'm going to introduce you to this legendary array operator. Oh my god, the array. This little square bracket operator thingy that we have in C. So this is how we would declare typically a buffer. So I'm going to go slowly and just hope you just make sure to follow, okay? So const, for example, const char pointer name Laura. This is how we would declare just a raw string in C. We don't have to change this. We don't need a string that we don't need to change. We are not expecting to be able to reassign this variable. This is just a constant string, basically. Now, there's also another way of declaring strings. Char, okay, we're keeping up. Let's say name1, and then these little brackets right here. And here, you specify the size of your strings in bytes. For example, I want my string to be, let's say, maximum of 5 bytes long, and here I can initialize my string of what I want to be. So, let's count. HELLO, that's 5. That's not gonna work. Because remember, we also need to include the null terminator. So, hello is 5 bytes long, and we only have 5 bytes of space allocated here, which means, on the stack here, which means it ain't gonna work. So, let's see. We could definitely... we could use hello. So hello right here. HELLO right here. Not quite good. Let's leave out the space for here. So let's have 6 bytes. So we need a null terminator, right? So Actually, maybe we can probably fit this in here, right here. So oh yeah, let's do Mike right here. Let's do Mike as name one just to keep it consistent. Okay, so there we go. So this is another way we can declare strings, especially if we want basically like a string of a certain size. Now, this would be an initialized array right here. So we would create an initialized array right here. So we initialize it to the name Mike. Now, let us print these two strings and show us the differences. So they're both strings, which means they use both the %s and %s, obviously. Very useful. Name and name1. So both of these are strings, respectively. But they're declared differently. So, right here it does print Laura, Mike, right? There you go. So, here we basically we print the string right here. This is a constant string initialized to a length of L. We don't know what the length is, so we can initialize it like this. And here we have an array declarator. We've declared an array of chars right here that's 5 long. So if I put let's say 5 here, this might throw an error. Yeah. As you can see, Mike 5, and look, what's this? Look at that. That is this is pollution right here. This right here is basically reading uninitialized memory. And why does that happen? Well, have you noticed something? Look, this, and why does that happen? Well, why could that be? Well, there is a problem here. This string right here automatically, this const char pointer name, this declaration automatically appends the null terminator at the end of the string after you declare it. Automatically. This does not. You see what happened here is we replaced the null terminator or the null byte at the fifth index at the end with a 5. Therefore, our print function didn't know where our string ends. It has no idea where our string ends. So it just keeps printing. Keeps printing and printing everything that's in the memory, until it encounters another null byte. So here, right here, it encountered, most likely encountered a null byte, and it stopped printing there. And that is the catch. That is why C is such a fiddly programming language. This one appends the null byte automatically. Therefore, we can have any length we want here. Laura, Bob, Mike work. But if you accidentally initialize it like this, where you remove this little teeny tiny null byte at the end there, it will just print random uninitialized garbage in your memory that you don't want. Isn't it just beautiful? What a great programming language, isn't it? So that's the reason why we have to remove this 5, because now this is initialized to Mike, and this last byte over here, this in the 4th index will turn into a null byte. Therefore now it's gonna print Mike without the garbage because it knows where to actually stop printing. That's the gist of it. Okay, I hope this is making sense. Again, I'm gonna repeat myself right here. So, in here, right here, so here I'm gonna mark this for you. So here with this type of declaration, you need to be careful. Be careful that you don't rewrite this. I'm gonna say the null byte / null terminator / null terminator. There we go. Because all strings in C are null terminated. We call them null terminated strings. So there we go. I'm just saying overwrite the null byte. There we go. Be careful that you don't overwrite the null byte. With this declaration, be careful that you leave that last little index at the end of your string empty. So basically, with const char pointer string, like this one, basically any length string, any length string, and then plus /0 automatically added after added. There we go. So there we go. So the 0 is automatically added. Let's check this this kind of declaration. So 5 equals Mike, right? So let's analyze this. So this is 4 bytes. So 4 bytes actual string plus 1 byte, which is the null byte right here. So null byte. Therefore, if we actually split this, so realistically, so the string is actually 4 plus 1. So 4 for the letters, and so actually the 5 is actually like this, 4 plus 1. So it's basically 4 for the letters and then 1 for your null byte. Together makes 5, so your string is a length of 5, even though you have four letters in it. And that's the reason why a string in C that's 4 letters long is actually 5 bytes long. So that's the reason why a string in C that has only 4 letters is actually, you know, a length of 5. So just so it doesn't get confusing later in the line. I hope this is helping. I hope I'm actually explaining this well. But like, that's kind of what you need to know, because I feel like this gets really confusing really quickly, and people might start asking, but you know, like what you know, and you know, you can hear people ask like, oh well, why am I declaring 5 over here when my string only has 4 letters? Surely it should be 4, you know, and then people just start getting confused like that, and they don't know what's going on. So it's really good to get these things out of the way early, just so, you know, we can build on top of these things, because in C, everything is built on primitive type. So if you don't know the basics, you can't really do anything else. So let's just take our time really explaining the basics. This is gonna be a hell of a long video, but please bear with me. You need to have a very strong and good foundation when you want to program in C. Okay? So let's just go to this very slowly and really take time to understand what these little nits and quirks actually are. So again, 4 bytes for the letters, the chars, 1 byte for the null terminator. If you overwrite the null terminator, you see what happens. So again, I'm going to overwrite the null terminator, and I'm going to show you what happens. There you go. Right there. So I removed the null terminator. So even though my string ended here, the actual compiler, or, you know, the actual program, the C program, doesn't actually know that this is the end, because I removed the null terminator. So it just continues reading the stuff in memory. So it just continues reading the memory more and more, and it just continues and continues until it encounters another null byte, and then it stops reading. So sometimes this could continue for a very long time, and you could really do some bad things in your program when you're not careful. So make sure you really don't miss this out. Make sure to really at first maybe really try to count the letters, maybe, or whatever helps you. Like maybe count the individual letters, like, oh, I have 5, so I need to have 4 letters, so 1 2 3 4, and just count them or something. Like just do something like that to help you. Like use something that would help you to count it, to just be careful that you don't mess up your memory, because this could be quite bad, especially in very larger programs. You could mess yourself up pretty badly. So there we go. So this happened because I removed the null byte. This happened because I removed the null terminator. So C doesn't actually know that this is the end. It just continues reading the garbage, the uninitialized garbage that's in the memory until it you know, obviously meets another null byte, and then it stops. So that's why we have this. So now if I put the 5 away and I leave the space for that null byte, you will see the difference again being that we really do get the string. So be careful, okay? That is very something that a lot of beginners get wrong and just get messed up on, and they might just, you know, get frustrated. Why is their program not working? Why is this and that happening, you know? That's why. So that's why your program might not be working the way you expected. So they're not quite identical, but they are identical, but also they're not really. So be careful. Also be careful about declaring other types like as pointers like this. These are not arrays, okay? This is wrong. So this only works for char pointers, okay? Exclusively. So be careful. I will recap all of this later, and then we're gonna have yeah, I will recap all of this later, and I will guide you through. So again, excuse me, I'm getting quite tired myself, don't worry, like this is exhausting for everyone. So I feel like again, if you have any more questions about this, I think I'm probably gonna link some kind of a social media, something in the description of the video, just so you can come and get into contact with me, and you know, we can explain it a little further if you need any help. So there we go, that's the char for you. Oh, I'm sorry, it's midnight right now and I'm recording this video because I really want to get the first video out there, the first C video out there, because it's been bugging me. Anyway, I'm gonna go and lower the temperature here because it's getting quite hot. Oh. Sorry about that, I just lowered the AC, but whatever. Okay, now we know how to allocate array like. And by the way, I also mentioned that this, for example, declaring char name, let's say 5, you know, Mike, this is correct. So that this right here is correct, right here. This one here is correct. And also int array 5, and here 1, 2, 3, 4, 5. That is also, this is, finally, we get to the point where this is indeed an array, and these curly braces are called array initializer list. We can use them, and this is indeed correct. So this will be indeed correct. So this is wrong. This is wrong right here. This is not how we initialize arrays. But for integers, this is correct. This is how we want to do it. So just remember that little quirk. Great. Okay, so there we go. So now over here we can so now we have already made this little array like string here. So now finally after all this time, you know what's really funny? I'm gonna tell you the funniest part about this. We haven't even scratched the surface. We haven't even started yet. That's the best part about this, is that we've literally haven't even scratched the surface. Like, we haven't even started, and it's been like almost 2 hours. So isn't that fun? Don't you just love this programming language? Anyway, so now I'm gonna also mention it, a little side note right here. Actually no, so now we can finally, after all this time, I can introduce you to the get. We can start talking about the gets function, the getS function. The reason why I needed to take you through all of this first is because the buffer is allocated like this, and that's the reason why. Like you need to know why we actually do it like this. If I just use the gets function immediately and declare the buffer like this, there could be a confusion about why I did it like that or whatever. So also the main difference is this is an immutable right here, so this is immutable. This is immutable. And this is mutable. So that is the difference between these two as well. Immutable, mutable. Immutable, mutable. Okay? Remember that. So now you know what's the difference between these two declarations and why we do what we do. So now let's get into buffers. Forget everything you know from Python right now. That is not, just forget it. All of the stuff that we did before with the TCP sockets in Python, that was called a buffer. Just forget that right now. We're going to talk about something else. Okay, so we declare buffers just like we do arrays. So here, this would be also a buffer. So if you want to take user input, you need to create something called a buffer. So char buffer like this, and you want to give this enough space to be able to basically fit something that you want to take from the user. So if you want, let's say, to take single words from the user, let's give this 12. Let's give this like 12 bytes maybe. So this would be our buffer where we will save our strings. So basically what we do is we will copy the strings from the user input into the memory of this buffer. So we're just gonna like transfer it like this. You just like here, you take this from here and you copy it to there. So that's what we're gonna do. Basically, we're just gonna move this here. How do we do that? Well, let me introduce you to a little keyword that you might not have heard of yet. And we do this because you know how this requires r size t buffer size, and it's in bytes. And how do we get that? Well, there is one little operator that I'm going to introduce you, the MVP of the C programming language, and that is the Sizeof operator. The Sizeof operator. And I know I hear you. What on earth is the Sizeof operator? Some of you might have never even heard about this ever. Like, what on earth is this Sizeof operator that you're talking about? Well, this Sizeof operator is very useful because what it does, it actually gives us the size of specifically stack allocated variables. It gives us the size that they are allocated of. So for example, I'm going to give you a little example. Sizeof buffer, in this case, from here, from this line 15, will give us is equal to 12 bytes, or just 12. So you can try this yourself. Please try this yourself. It returns and if you want to print it, this takes in the %d as an integer. But yeah, so please try this yourself. So the Sizeof operator, it returns the size of your stack allocated variable that you've allocated, the size of this, so the memory. Let me give you an example. Like, I know this is taking a long time just to get to the user input, but trust me, we will get there. But the Sizeof operator is very important. So, important to talk about. So, Sizeof buffer in this case will be 12. It will give you 12. See, 12 bytes right here. We allocated 12 bytes. The Sizeof just gives you the size of the buffer right here. It's 12. And there you go. I can prove this to you. So let's say, let's allocate a char. Let's do buffer. And let's give it 12, right? So this is uninitialized 12. So this is called an uninitialized variable. If you put an equal sign here, this is initialized variable. This is an uninitialized variable. This variable right here, right now, if you compile and print what is in this variable, it will be 12 bytes of literal garbage. And I can prove it to you right now. So if you do printf, and let's print this as a string, and let's print buffer as a string. So what do you think will be in this variable? It's an uninitialized variable. It kind of just sits there, doesn't really do anything. Well, what this will print is just a bunch of trash, a bunch of garbage, as you can see. Right here. Right there. You see, this is what it prints. Just 12 bytes of uninitialized, useless garbage that we can't really do anything with. Because this memory hasn't been initialized. We are just reading garbage, just uninitialized garbage. This means nothing to us. This is meaningless. So that's the reason why we always need to initialize our buffers or our uninitialized variables. Now, so this buffer is uninitialized, but the size of this buffer is still 12 bytes. So I'm gonna let's say we'll give you an example of the Sizeof operator. So the Sizeof operator, it returns an integer. Awesome. And now let's do Sizeof buffer. So this will return the number 12. And I'm gonna prove it to you right now. 12, right here. You see? Returns the number 12 because we have the 12 bytes allocated to the stack right here. So right here. So we allocated the 12 bytes of memory to this variable right here, and as you can see, the Sizeof operator is very useful because it returns the size that we allocated. So this is 12. There you go. So that's my kind of like slight introduction to the Sizeof variable operator that is gonna be useful in this case. I obviously need to introduce you to all of this before we actually get to user input, because all of this is important in grabbing user input. So now, I'm gonna show you the proper practice of, so now I'm gonna code how I would go about like grabbing user input and printing user input. And I'm gonna show you the correct way of doing it, and we're gonna explain the code and what it means and what it does. So we've already talked about the Sizeof operator and about the uninitialized, buffer here. So now, repeat after me. We will need a new include. So now we will need an include something called memory.h. This memory file, this memory.h file, for example, contains a little function called memset right here. This function is a function that is used for zeroing out uninitialized variables. So basically a variable that you uninitialize because you want to put something in it later, but you don't want the variable to contain a bunch of uninitialized garbage that you can't really work with. Obviously Microsoft has, I think, a macro for this. It's called zero memory. If anyone here is working with Microsoft, you've probably seen this zero memory macro somewhere. It's basically just made on top of this memset function, but this is just for Windows computers. Linux users unfortunately have to stick with this memset function, unfortunately. So it's always a good practice to zero out memory of your uninitialized variables, because if they contain uninitialized garbage, you might not be able to concatenate strings together because you're missing those null bytes there, and it just turns into a whole mess. Trust me, believe me, it really does. So the first step in getting the user input will be to declare a buffer, because we obviously need to store the user input somewhere. So let's create a buffer of 12 bytes. Okay, well, this is uninitialized, and as you've seen previously, it contains a bunch of garbage that is meaningless. So we need to turn this bunch of meaningless. So now this variable, this array right here is completely useless. It's completely worthless because it contains a bunch of uninitialized garbage that won't help us in any way. It's not useful for us. So what we do is, from the memory header, we use the memset function. This memset function right here. And let's talk about this little memset function. Don't worry about the void pointers right now. Don't worry about that. We will talk about what that means later in other parts of the video. I will cover pointers in more detail later. So what this is, what this wants is basically a pointer or a memory address of the destination that you are saving this. So basically the memset needs a memory destination of the variable that you are trying to zero out. In this case, it's a buffer. So this one, the second parameter, is a value that you want to set the memory of that variable to, in this case 0. And this is the size of the buffer, this is the size of the memory that you want to set to 0. And in this case, it would be the size of buffer. So in this case, 12 bytes of memory. So we want to set 12 bytes of memory to 0 in this variable right here. Now, you've seen that this little first parameter here is something called a void pointer. So yeah, so you've seen this as a little called void pointer, as you can see. So this is the memory address of the destination that you want to set to 0. So if this, so now we have to talk about, okay, but so now I think some people might go like, oh, wait a second, well, if it's a memory address, why not just put the ampersand there? And this is actually not correct, because this would be a double pointer. So you're basically passing a double pointer here, so this needs to be done like this. Because, and I'm just gonna make a side note here, so let's just make a side note here. So a pointer and this are equivalent. Which equivalent. There we go. So these two little these brackets right here and then this are equivalent, which means that char name 5 is basically kind of similar to char pointer name, but not quite, because this at the same time, while being a pointer, also allocates 5 bytes of memory and initializes 5 bytes of memory alongside it. So they're kind of equivalent, let's put kind of equivalent. They're kind of equivalent, but they're kind of not. It is a pointer though, like arrays are kind of pointers in a way. We will show why when we're gonna like sort of look at the heap allocation and why it's a hell of a confusing mess. But you should still treat these brackets and these pointers as two separate things, and you should not try and interchange them. Please don't. You're gonna get confused. Just keep them away from each other, and but if it's asking for a void pointer, you can pass it like this, because this still is a pointer in and of itself. So this is basically how we zero out. So now, let me compare it. So now, let's say we print the string buffer, right? So look what had happened before. Look at this. Oh, look at this. Just a bunch of garbage, uninitialized garbage that is completely useless to us, right? Good. Okay. So this is exactly what we want, right? Let's put a new line character to make it more clear. So this is this is exactly what we don't want. So, and to demonstrate how this function works, I'm also gonna put printf here, just to demonstrate why this is necessary. So here as you can see, we printed out this buffer when it's uninitialized, so it just contains a bunch of uninitialized garbage that we don't want. Then we call the memset function, and we set the memory at this location to 0, and this is the size of the memory that we want to set to 0 to, so it's the size of this buffer. And then let's print it after. So as you can see, we should only be able to get 1. There we go. As you can see, here it prints the uninitialized garbage as we expected. This is the first printfs, but then the second printf function doesn't actually print anything. And that's exactly what we want. So now, if you did this, you've basically successfully prepared your buffer for writing into. So now this buffer right here is prepared for us to copy or move strings into all we want, right? So now we can start actually start getting user input. because this is actually the buffer that we're going to be writing the stuff from and don't get it confused. User input basically takes stuff from a stream called standard in, std in. So that is the stream that we're taking the data from. So we are taking the data from standard in and saving it right into this little variable. So we need, with this memset function right here, we have prepared our buffer to be written into, to basically be able to hold data that's meaningful to us now. So now we can actually start writing into this variable. So what are we gonna do? Well, I'm gonna print a little string here. I'm gonna say enter your name, for example. So I want the user to enter their name, and here I'm gonna get their name using the gets, which basically gets the one line. So this basically gets the whole line and saves it into a buffer. So there is something called scanf. This basically reads the line until it encounters a space and it terminates read. But there's also a line called gets, which is basically it scans the line until it encounters a new line character and then it stops reading. So that's the difference between the two functions. So we want to read the line that our user provides until new line. So we're going to use the gets function. So as you can see, it requires a char. As you can see, a char pointer buffer. Well, that's right here. So this is the little guy we have there. There we go, buffer. And there you go, the rsize what we were talking about. So our char pointer would be this little guy right here. This is our buffer that we want to save strings to. So we're gonna put it there, and here we use the good old Sizeof operator that I've introduced you to like a couple of minutes ago, and we're just gonna simply say buffer. Now this is used to check if the input that from the console will fit into the buffer, and if it won't, it's gonna throw an assert exception. Or it will throw an exception basically saying that, oh, your input doesn't fit into the buffer, you need to make the buffer larger. It will basically say that. So that's the reason why we are passing this, just to make sure that we don't get weird memory corruptions, because it can happen. So that's why we're passing in this Sizeof. So to recap, this first parameter is the variable we want to save the string to, and the second parameter helps us determine whether or not this buffer variable is large enough to hold our data. There you go. And now all that we have to do is just print our result into the console. So we use the printf function again to print a string, and let's print my name is, let's say, buffer right here. And now this will print basically data from the user input. So let's run this. As you can see, it will ask us for our name. We provide our name. So I am Mike. There you go. My name is Mike. As you can see, there you go. Now we have successfully taken user input, saved it into a buffer variable, and then we successfully printed it out to the console back to the user. And this can be any name as long as it's less than 11 letters long. So I think my whole name fits here. Yeah, as you can see right here. So as long as this name is at maximum 11 letters, it will fit into the buffer. So there you go. Right here. So now, if you manage to program this yourself, you have now successfully got the input from the user and you've successfully printed it into the console, which is remarkable. The fact that you're still programming in C, so it's still remarkable. So well done. You're doing really well. Actually, I'm gonna go back and talk a little bit about the memset function again. So this memset, when we're talking about chars in specifically, so what this function does here, it basically sets all 12 bytes. So all 12 bytes get set to that. So when you call this memset function on a char pointer like this, or a char array, it will set all 12 bytes in that array to the null terminator, or the null character, which means that we can also concatenate strings to this. So there you go. So all 12 bytes will be the null terminator, basically. Okay, good. So now we've successfully got the input from a user, and you've managed to print it back to the console. So well done. You have successfully endured this torture. So I think I'll leave the integer parts for next time. Actually, I think I would probably want to. I think I'm probably also going to show you how to declare an array real quick. So we have now seen it how to do it. So now I'm just going to quickly show you offhand how you would do it with integers. So declaring an array of integers is basically done like this. So array, let's say 3, and then we would use the ArrayList initializer and put 3 numbers into here. Since this does not need a null terminator, we basically, these 3 elements are right here. So these are 3 elements right here, 1, 2, 3. We don't need to put 4 because we don't need a null terminator when it comes to integers. You know how I told you that each char is 1 byte? So you know how I told you that the char buffer, this was 12 bytes of data? That's because a char, as a char, should be, yeah, so you know how this is 12 bytes of data? That's because char, the size of char, like this, is 1 byte. And that's the reason why putting 12 here is basically 12 elements also equals to 12 bytes. That's the reason why. And right here I can prove it to you right here. So let's actually show it to ourselves. So Sizeof char right here. This will give you the size of a char in bytes. And as you can see, it's really 1 byte. But what happens when you're changing from an integer is that you have to remember that an int is 4 bytes. As you can see, 4 bytes. So one integer is it requires 4 bytes of memory to be stored. Now, that's where the problem becomes. Because while this array has length of 3, it basically, it's the array has length of 3, but the size of array is not 3. The size of the array is actually the size of this array is 3 times 4 bytes. 3 times 4 bytes. So which is also 12 bytes. So as you can see, this array of 3 integers is 12 bytes in size. So in C, there is a very clear distinction between length and size. They are not interchangeable. I repeat, length and size in C are not interchangeable. Do not get that confused, okay? They mean completely different things, which means that the length of an array might be 3. You have 3 integers, but the size is 12 bytes. And right here, as you can see, we can prove this. So if you put, let's say, a buffer right here, which would be D, buffer size, and then R size, right here. Now what we will see that now we should see that they're exactly the same size. So we should see that the buffer size here will be 12 bytes and here will be 12 bytes. As you can see, they are indeed the same size. So these two arrays, so this buffer of 12 between the brackets takes up the same amount of size, same amount of space in memory than the array of 3 integers. So that's kind of what I'm going to make clear. The number you're inputting here is the length of your array, not the size of your array. Remember, length, not size. So that's why I said the char and strings in general are very, very special little things, because since a char is 1 byte, therefore the length, so the length of a string, the length of a string is indeed identical to its size. But this is only true for strings, no other data types. And that's the reason why, even though this array has 3 and this array has 12, even though these two numbers are different, they still have the same size in bytes. And that's the reason why. That's the reason why. So do not get this confused. If you are declaring an array like this, so int array would be like this. So it goes length, right? Here's length, array length, okay? So it's array length. It's the length of the array that you put between these brackets, not the size. Remember, they don't mean the same thing like in Python, okay? The array length is 3, the array size is 12 bytes, okay? Remember that. Remember that. Just to make it super, super clear, because again, you know, if you're a beginner, you couldn't really easily get these things confused. You really could, and that's you know, the reason why I'm so empathetic, I guess, to clearing this up. So here, basically what we want to do here is we want to right here, so the length of this array is 3, but the size is 12, which means that this for loop right here will not work. This for loop is bad. This is bad. This is very bad. This is right here is very bad. Like this for loop, no good. This for loop, bad. Very, very bad. No good. No good at all. This is for a data type of int. This is actually 12. Remember, this is 12, which means that technically you're saying that your I is less than 12, which means this loop will loop until your I is 11. But remember, you only have 3 elements in this array. And this is the reason why I am trying to hammer this home, that array length in C is not the same as array size. Because you can make this mistake really easily, and trust me, I myself had made this mistake a couple of times. And it's not good. So how you really want to print this array is using a for loop that looks like this. Int I is 0, I is less than 3, and I++. Remember, I is less than the length of the array, not the size of your array, okay? Remember. And here, we just simply say D, and then we just subscript. Just like you would in Python, do it like this. And this is going to print your array of integers. And that, ladies and gentlemen, is the last. Then that, ladies and gentlemen, concludes this lesson on C for beginners, okay? There you go. 1, 2, 3. What else do you need? Beautiful, amazing. I'm so exhausted. Holy shit. I bet you are also exhausted as well. I mean, C is very hard. But trust me, the next videos should be a bit better. it shouldn't be as this complicated and this hard, you know. So you can subscript it just like in Python, like you would print it like this. But remember, this has to be the length. So you could technically either make an array called length that's equal to 3, and then you can pass it here like this. Oh fuck, you can pass it in there like that. That needs to be initialized. It needs to be uninitialized for that to work. So okay, that is okay. It needs to be okay, that will work. We will show each other how we can make that work, but that requires, again, I need to explain a whole tirade of things all over again because that's completely different. So for now, we can just define a macro. You know, a macro using the hashtag define. We can define a macro of length. Let's say length 3, and then we can just use the macro here, like so. And then here we can basically just say length. So in this case, we're just going to use a macro. So we define a macro like this using the define keyword for the compiler flag, and we use it as a replacement for 3, and then we can just put it here like this so we can keep consistent throughout our program. I'm going to show you how to do it with variables later, but that would be a story for another time. So for now, you can do it yourself by defining a macro like so, and then putting the macro inside the brackets and here, and this will work exactly the same. And this is good, and you might be wondering why this happens. Well, this is good for keeping consistency, you know, so that's the reason why that works. So I am going to leave this here. I'm going to go to sleep now. I'm going to go to bed, and I'm going to go to rest because this was very exhausting, and I think you are also pretty exhausted. So I'm going to give you some time to absorb this, and yeah, I'm going to move on to Python next time. And okay, let's recap this. So we are programming in C11. We use the printf function that prints to console. Gets, which is a function that gets user input. It basically gets one line, and it basically reads input until it encounters a new line character. This takes into parameters a buffer variable and a size of that buffer. Then we talked about that. Then we've also talked about how to declare a string. So an immutable string. In C is declared const char pointer like this. This is your typical immutable string of any length that you can declare if you just need, you know, an immutable constant string. Then we also talked about the printfs and about the many sort of like formats that it has. So you got formats. D, remember, is an integer, S is a string, U is unsigned, and then C is a char. S, so D would be an integer, and S is a string or const char pointer. This could also be a char pointer, or basically a char array like this. So it could be any of these three things right here. So these three are valid, just, you know, for the beginners, even though these, this, and this are the same thing in a way. Just for the beginners to know, these three are valid for the string format right here. So now we've also talked about how char pointer is a string, like it's an array. It creates an array of chars. But we also the fact that you can't declare an array like this for any other type. So integer pointer name will not create an array like this. So be careful on that. Keep that in mind. That is very important. For example, yes, so let's say char. So for example, this char pointer name Laura indeed is an array of type char. Then we can subscript it like we would in Python. For example, name at index of 0, it would give us L, which is a char from the name Laura. And obviously, this is just another recap of the formats. So %s is a string, %d is an integer, and %c is a char, remember. Then we've also talked about how char pointer and char the square brackets. There we go. How square brackets are basically kind of the same, kind of identical, but are not really. They are pointers. Like this is a pointer, but a pointer to an array. Like, you know, they are identical to a sense. And obviously I've talked about when you're gonna use these bracket initializers right here. If you're gonna make you choose the brackets, be careful that you don't override the null terminator. This null terminator is always at the end of your string. So if you have, let's say, you know, if you have a string, so char name, you know, like, yeah, I think I talked about it later as well. So be careful to not override your null terminator, which is always at the last index of your string. Then we obviously discuss the differences between the const char pointer and a char array declaration. So a const char pointer or a char pointer like this, if you put any length string here, plus it automatically adds this null terminator right there. Oh, sorry about that. Oh wow, that's an update for my SQL database. Ignore that. That was just an update for my SQL database. It's fine. So this right here automatically adds that null terminator there. Right here. So oh, okay. So this will automatically append the null terminator. However, this will not. So in this, you're just like replacing the null bytes with letters. So always try to kind of think about this type of declaration as the length of your string of like the letters plus 1. So if you want to store, let's say, a string of 4 letters, plus 1, that would be 5. So here between these brackets you would put 5. If you want to store a string of, let's say, 10 letters plus 1, that would be 11. So you put 11 between these two brackets. And that's like a very good sort of rule of thumb to always get it right, because you always need to leave that null byte at the end. And you saw what happens when you overwrite that null byte. We just start reading to memory that doesn't belong to us. You know, we don't own that memory. That's not our memory. You know, it doesn't belong to us. Therefore, we shouldn't be reading from it. You know, that's the reason why it's always good to make sure you don't overwrite that null byte, because once you do, it will just keep reading until it encounters another one. And you're reading memory that, again, doesn't belong to you. It's not good. It's very bad. Don't make sure it doesn't happen. So 4 bytes actual string, 1 byte for the null byte. You know, 4 bytes because it's chars. Again, char is 1 byte. That's why 4 bytes. I can kind of see how this is all starting to make a little bit of sense, you know? Like, how is it all coming around, you know? Can you kind of start seeing a bit how this is maybe making a little bit more sense? Like, how it's this, like, coming around, this, like, one big circle. So, yeah, I hope it's starting to make at least a little bit more sense. Like, at least a tiny bit more sense. So for 1, 2, 3, 4, so that's 4 for the actual letters, plus 1 as the null byte. Therefore, we will put 5 in between these brackets. Let's say if I wanted hello, you know, if I wanted to store hello in this, you know, so that's HELLO, that's 5 letters. But remember, this is not counting null bytes, so 5 letters, hello, and then plus 1 for the null byte, which means we need to put 6 here to store the string hello. And that's how we would go about it. So we will put 6 right here to basically store a 6 right here to store the string hello. Hope it's making sense. 5 for the hello and 1 for the null byte. Remember, so that's 5 for the hello, 1 for the null byte. You put it together, you get 6. Then for integers, we got 5. This does not require any null terminators nor null bytes. So the length, remember the length of your array is the same as the amount of members you have. So if you put 5 here, then we would have 5 integers in our array. But this is not the same as the size of the array. Remember this little fact, this little thing. So an integer array of 5 will store 5 numbers maximum. An integer array of 10 will store maximum 10 numbers. And remember, this is the maximum size. So you don't have to use up all the memory, because all the other would just be down to 0 if you use the equal sign. We will talk about uninitialized arrays and uninitialized variables later, and how we can use the memset function to basically make those uninitialized variables useful to us for writing like alongside, like later in the code when we need to. So there we go. So this is how we declare an uninitialized variable. This variable, obviously we talked about, it contains a bunch of garbage, a bunch of nonsense, uninitialized memory that doesn't belong to us, we're not supposed to read from. Just nonsense, you will get nonsense. And to be able to actually work with this, we talked about the memset function from function from the memory.h file. This function takes in a pointer to our variable. So variable, it takes in a pointer to our variable, and it takes in the value that we want to initialize the memory to, and it takes in the size in bytes, aka you want to use the Sizeof operator on our, let's say, buffer right here. So in this case, the memset here. So, and a good example of this would be, so for char, so memset right here, memset memory set, we would put buffer right here, then 0, and then Sizeof buffer. Remember again, pointer to a memory address we wanna set to 0, which would be this right here. Then the actual value we want to set the memory to, which would be 0 in this case. And then the size of the memory we want to set 0 to, which would be the size of this little guy here. So that's how this basically works. The reason why we don't use the ampersand is because this would make it a double pointer. So you would have a pointer to a pointer, which doesn't make sense in this case. Since this is already technically a pointer, we can just pass it in like this and it will work. So there you go. So we talked about this. We will, don't worry, do not worry. If you still fully don't understand the memset function, I will go through this function later in other videos, and I'll show you just how insanely useful this function is. But bear with me. Then I've introduced you to our best friend in C, which is the Sizeof operator here, and it basically gives you the size of your variables in bytes. But but of course there are nuances to this operator, because this is C and everything. There is nuances to everything in this, so it's not as straightforward, because this is C, and of course nothing is that straightforward. So this does not work on pointers, and I will explain it to you why in a second. Okay, I'll explain it to you why in later videos, because this is C and everything has to have nuances. So, but for now, this is enough to, enough stuff to fry your brain with for now. So I will leave you here. I think we've covered some decent stuff when it comes to beginners. Just really explaining how things work in detail, just to make sure that you really understand it. Then we've also kind of explained how these two are kind of equivalent, a pointer and brackets, but not really. They kind of are, but are not really. We will obviously explain this and show this along the way as we get to more progressively higher stuff, harder and harder things, and start programming, start passing arrays into functions and stuff. We will obviously talk about why they are kind of interchangeable and why they aren't in that time. And we also talked about how when it comes to integer arrays and generally non-char arrays that are of different type than char, that the idea of size and length is very important, and then the length of your array does not equal the size. So here I'm going to say the length does not equal size in this case. So the length of your array is always given between the brackets, This is basically how many members does your array have, and the size of your array is given by the Sizeof operator. And in this case right here, I've given you a perfect example of how this works. So our array has a length of 3, 1, 2, 3, but the size is not 3. The size is 3 times 4, 12 bytes. Why 3 times 4? Because we have 3 elements of type integer, and since integer is 4 bytes, we have to multiply it by 4. So 3, 1, 2, 3 times 4 gives us 12 bytes, and that's why 3 times 4. I hope that actually helps you out understanding a lot more about this programming language that you thought. And honestly, I really just hope that it will somehow convince you that C isn't as difficult and as hard as maybe some people are stigmatizing it to be. Like, you can learn this. You can learn this. It is possible to learn. It will just take a lot of time and a lot of effort, but it is possible. Like, you can learn this, you know? I just wanted to kind of, because I feel like there's a lot of, I feel like, and the reason why I wanted to make this series is because I feel like there is a lack of proper explanations for these things. Like, when you see people programming in C, they always just do things, and they always just like code, but they never really tell you why things work the way they do, or like why they do the things they do. You know, they kind of just assume that you know it. And, you know, I kind of wanted to make this series as a way to kind of, you know, give this programming language, or make this programming language a bit closer to newbies, you know, and people who have never programmed it. And because, you know, like obviously experienced people might know this, but people who are new to this programming don't know any of this. You know, they have no idea. You know, they don't know that, like, oh, you know, the length of an array and size are two different things. Like, you know, I just feel like some things, I just don't think I should assume that everything is common sense, especially to someone who has never seen anything even remotely close to C. So that's why, like, I'm really taking my time. Like, I'm sorry this video is so long, but I really wanted to go into, there's just so much nuances to cover in this programming language. There's so much, like, complicated stuff. And, you know, I really, really want you to understand it. And I'm really going into detail, and I'm going kind of slowly as well to kind of really make sure. And I'm trying to, like, repeat certain things as well, just to really hammer it home into your heads that, like, this is how it is. So, you know, obviously these are going to be long videos, but I think they should be very explanatory, and they should offer a great amount of education. And I hope that at the end of the day, there are going to be people who are going to take away something from this and going to learn something at the end of the day. At the end of the day, I just want you to learn something, and that's all. And, you know, I'll always say this. You need to go and dig in and program this yourself. All of the stuff I did, ideally, you want to do it yourself. Just grab, like, GCC if you're on Linux, or grab some, I don't know, Visual Studio Code, and maybe Clang or whatever, or just some other available Windows compiler, or maybe Visual Studio 2019. It's like a free Microsoft free thing. It's free by Microsoft that comes in with a C compiler already. It's actually MSVC, the one I use. By the way, you can also get, I think, for Microsoft, if you're using Windows, you can install Microsoft Visual Studio 2019. I think it's free. That one should be free, and it comes already with all the tool chains you need to program in C. So the Microsoft Visual Studio 2019 is free, and it comes with MSVC, a Microsoft Visual C compiler. That's the one I'm using now. Currently, I am using MSVC on this computer, and I'm compiling this through MSVC, and I'm using Clang as, like, Clang with MSVC. And for Linux, you can use GCC and Visual Studio Code to basically do what I do. These libraries should be the same for Linux, or you can just Google the equivalent of these libraries in Linux. That's fine, since Linux is also programmed in C. You should have these libraries already, it should be fine. But yeah, so that's the gist of it. I will end this video here. This was a fucking long video, holy shit. And you know what the funniest part about all of this is that we haven't even started. Like, this was literally just like, we've just scratched the surface right here. Like, this was literally just like just a little like peek in the surface of the C programming language. So hold on tight, it's gonna be a ride, but it's gonna be a fun one, I promise. So this is basically how I would go about it, and we're gonna do some fun projects in C as well. And yeah, I hope this will help you. I know I've been rambling on a little bit, but I kind of want to address the point of this series. The point of this series is to make some like beginner friendly or accessible tutorial to give to people who have never programmed in C. I just don't really want to do a bunch of things and then people start asking why this, why that. Like, I just want to kind of explain this thing. So we're kind of now, so right now as it stands, we've already completed the first steps into C programming. So just I hope you followed along. If you didn't, that's fine. But I really encourage you, try to program all of this stuff that I did yourself. You're more than welcome to use this video as reference if you get stuck or whatever. I'm probably also gonna include like my contacts to my socials on me somewhere in the video description, so you can just contact me if you need any help. It's fine, you know. And yeah, so yeah, this video is gonna come out very soon, so look out for it. It's probably gonna come out on Friday or some shit. I don't even know. If it's actually gonna come out, it's gonna come out, well, today. But yeah, I actually don't know when this video comes out, and this is actually not even important. But it should probably come out this day whenever I upload it, I guess. So the next video about these things will come out sometime next week, probably, or maybe this weekend, ever even, I don't know, like, it depends how tired I am. But yes, I'm gonna go to bed now, so goodbye. I'm gonna go to bed now and think about my existence and my life. So goodbye, see you later.